shall be looking at the generation of the Lagrange interpolating polynomial formula. Now, so we have Lagrange interpolation. The Lagrange interpolation is basically the linear, the quadratic, the cubic, but generally we'll consider the quadratic interpolating polynomial of the Lagrange form as one of the most useful aspects of Lagrange interpolating polynomial. We are going to look at the second order Lagrange interpolating polynomial, which is expressed as sigma n equal to 0 tending to 2 of function and Lagrange Ln function of x function subscript n of this. This sum total is a reflection of the general Lagrange for quadratic interpolating polynomial, which takes the precedence of polynomial 2 function of x is equal to Lagrange not function of x subscript 0. Now Lagrange subscript 1 function of x function subscript 1 of x plus Lagrange subscript 2 function of x now subscript 2. This is quadratic interpolating polynomial expression for Lagrange. We are going to generate L naught, L subscript naught, L subscript 1, L subscript 2, which are the consecutive values for a Lagrange expression that will be inserted back into this equation or this expression to form the quadratic interpolating polynomial. That is degree 2. So L naught, as it is being generated from the constant values that will be given, x naught, x1, x2. Note that if it is linear interpolation, we will be looking at x naught and x1. If it is quadratic interpolation, we consider x naught, x1, and x2. Take note. Now, L naught generation, we have x minus we close, x minus we close. The base value determines the preceding terms in the formula. L naught is here, L subscript naught is here. So the base value here should be x naught minus, you also close, you open and close. X naught having been picked here, the next consecutive value is x1, you fit in x1 here, and whatever is here is what is here, you have x1. The next term in the orderliness of chronology is x2. And this gives you x0 minus x2. Take note that if you have x0 here, you have x0 here. If you have x1 here, you have x1 here. If you have x2 here, you have x2 here. This is for L subscript naught. L subscript 1, function of x, is equal to, you have your x minus close, x minus close. You now also have, because of the L1, the generation starts from here, x1 minus the first consecutive ordered values in the precedence gives x naught, not x2. So you now have x naught here, x naught here. So whatsoever is here is what is here. The next term that has not featured in this expression is x2. You fit it in, and you now have x2. You close. So take note that value x2 must correspond vertically. Then the last Lagrange expression, which is L2 subscript 2, is generated as x minus you close, x minus you close, divided by, this is 2, so here should be x2, take note, minus in the orderliness of chronology, you have to pick the lowest value in the consecutive form. In a consecutive form, x naught comes first. And you have here x naught too. So what you have here is x1 minus x1 close. Now, the last case, as you can see, since 2 is here, you insert x2 here. We are now left with two items, which is x0 and x1. In the orderliness of chronology, x0 comes before x1. That is why we are working with x0 and x0. Then the last value, which is x1, we fit it in here. Take note that whatsoever is here is what is here. Then this expression will fit into this general equation finally to give us the insertion, and it will now be inserted as polynomial of order 2. Polynomial of order 2 is equal to initial Lagrange L subscript naught, which is this term that you have here. So you will now be having x minus x1 into x minus x2 divided by, which we have generated there, x0 minus x1 into x0 minus x2 plus multiplied by f0 function of x plus, you continue with L1. L1 again is x minus x0 into x minus x2 divided by x1 minus x0 into x1 minus x2 close multiplied by f subscript 1 function of x plus, as you can see, when I'm done with this, I go to this. So we're in the last stage now. So we are going to take x minus x0 into x minus x1 that we have generated. Then you have x2 minus x0 into x2 minus x1 close f subscript 2 of x. So we have this joint expression as quadratic interpolating polynomial formula. Take note that this was generated from this initial work we did. Having generated this, we insert it here to get this joint expression, which is finally given as this. Take note.